We are continuing with the solution of the International GCSE Maths B June 2025, and we'll be solving questions 18 to 26 in this video. Question 18 says the incomplete table and the incomplete histogram give information about the number of minutes that 900 flights arrive late at an airport, and these are the range of your time, and that's the frequency. We're given a graph, and the question says complete the table and the histogram. So from 0 to 30, we don't have the values for the frequency density as well. So the frequency density for 16 to 20, the frequency is 180. So I'll make a separate column for the frequency density. That's going to be frequency divided by the class width. So frequency is 120 divided by class width is 60. 120 minus 60 is 60. So that's going to be 3. And from the graph, we can see that that value is 3. So this must be 1, 2, 3, 4, 6, 8, 9. So the first bar is from 0 to 30 with a height of 9, and the area of the histogram gives you the frequency. So 0 to 30, the width is 30 and the height is 9, so that's going to be 9 into 30, that's 270. So the frequency for this is going to be 270. Same goes for here, 30 to 60, the width is 30 and the height is 7. So 30 times 7 is 210. So that's going to be 210. Okay, so for this, the frequency is 20 and the class width is 60. So that's going to be 2. 120 by 60 is 2. And here the frequency is 120 and the class width is 120. So that's 120 divided by 120. That's just 1. Okay, so for 120 to 180, we have a frequency density of 2. So we have there, and from 180 to 300, we have a frequency density of 1. So that's 1 up to 300. And that's our complete histogram. 18b says Sam selects at random one of the 900 flights. Find the probability that this flight was late by greater than 120 minutes. So to find the probability from a histogram, we have to think about the areas. All right. Okay, so let's look at the histogram greater than 120 minutes. We already have the table as well. We can use the table here as well. So the number of flights that were late by more than 120 minutes were this 120 and this 120. So the total number of flights that were late by more than 120 minutes were 240 in total out of 900. So 240 is my desired number and 900 is the total number, and that is 4 by 50. Question 19 says f is directly proportional to g squared, and f is equal to 9 when g equals 5. And so we can write f is directly proportional to g squared, and f can be written as k1, that's our constant, we'll just into g squared. And when f is 9, g squared is 5 squared, so 9 by 25, that's the value of k1. And g is inversely proportional to h. G is inversely proportional to h, and when g is equal to 5, h equals 4. So we can write g is inversely proportional to h, and so g is k2 times 1 by h, and g is 5 when h is 1 by 4. All right, k2 is going to be 20. So we have a relationship between f and g squared. So f is equal to 9 by 25 g squared. And we have an equation in g and h. That's g equals 20 into 1 by h. And you were asked to find f in terms of h. So I can replace g here. So from here we can write, therefore f equals 9 by 25 into 20 by h whole squared. So f comes out to be 9 by 25 into 400 by h squared, and 25 times 16 is 400. So that's going to be 144 by h squared. That's our f. Question 20 says, a solid right cylinder is made of wood. The mass of the cylinder is 2140 to the nearest 10 grams. The radius of the cylinder is 8.5 centimeters to the nearest 0.5 centimeters. The density is 0.7 gram per cm cube to the nearest 0.1 gram per cm cube. Given the density is mass by volume, and taking the value of pi as 3.142, calculate the lower bound of the height of the cylinder, showing all your working. So density is equal to mass by the volume. And we have a right cylinder. So for a cylinder, the volume is pi r squared h. All right. So that's going to be density equals mass by pi r squared h. We want to find the value of h. So h is going to be mass divided by pi r squared, the density. Okay, so to find the lower bound of height, because m is at the numerator, we need the lower bound of m. Pi is a constant. The radius and the density are at the denominator. So for both of these values, we need the upper bound of the radius and the upper bound for the density. So let's find them first. So we need the lower bound for mass, the upper bound for the radius, and upper bound for density. Okay, L is for lower bound and U is for upper bound. So to find the lower bound, first we have to do this. It's rounded off to the nearest 10 grams, so to 10 divided by 2, that's 5 grams. For the lower bound, we subtract 5 grams from this, 2140. So the lower bound is going to be 2140 minus 5. That's 2135 grams. That's the lower bound. To get the upper bound, we have to add 5 grams to it. And for the radius, it's 8.5 to the nearest 0.5 centimeters. So we have to do 0.5 divided by 2. That's 0.25. And for the upper bound, we want to add this value to the radius. So 8.5 plus 0.25. That's 8.75 centimeters. And for the density, it's given to the nearest 0.1. So 0.1 divided by 2 is 0.05. So we'd have to add 0.05 to 0.7 to get the upper bound. So 0.7 plus 0.05, that's 0.75 gram per cm cube. So for the lower bound of h, we write these values. The lower bound of the mass 2135, and pi is 3.142. That's what the question says, times the radius squared. So that's the radius. That is the radius. So 8.75 squared times the density is 0.75. And this will come out to be 11.834 centimeters. And the question says to give your answer to one decimal place. So the answer is going to be 11.8 centimeters to one decimal place. That's our answer. Question 21 says the matrix A is given, A minus B is given, and C is given. Find the matrix B. We have to find the matrix B, giving each element of B in terms of P where appropriate. So A minus B is given as 1, B, negative 2P, and 4. So if we change sides, B goes to that side, this matrix comes to this side, we get A minus this matrix, 1, B, negative 2P, 4 is B. And A is given 2 minus 3 minus 5, 10. So B is going to be 2 minus 1, that's 1. And minus 3 minus B, that's minus 3 minus B. And we have minus 5 minus of minus 2B. So we have minus 5 plus 2B. And we have 10 minus 4, that's 6. And that's our B. Okay, question B says find A inverse. So to find the inverse of a matrix, if a matrix is given, let's say A, B, C, D, the inverse of this is going to be 1 divided by AD minus BC. That's called a discriminant. And the matrix is going to be A and D will switch places. So D, A, and B and C will become negative. Minus B and minus C. So we had A as, so A inverse is going to be 1 divided by 80. So that's 2 times 10 minus BC. So that's minus 3 into minus 5. And the matrix is 2 and 10 are going to switch places. So that's 10 and 2. And 3 and 5 change the signs. So that's 3, 5. And that's going to be 1 divided by 20 minus 15. That's 5 into 10, 3, 5, and 2. So the matrix becomes 2, 3 by 5, 1, and 2 by 5. So we multiply this row into this column. That's going to be the first element. So we get 2 into 4, that's 8, plus minus 3 into minus 1, that's 3. And then again, we multiply this with this column. So that's going to be 2 into minus 5, that's minus 10, minus 3 into minus 3 into 3, that's minus 9. And again, we multiply this row with this column. 2 into 2, that's 4. 2 in minus 3 into 8, that's going to be minus 24. Now, we multiply all the columns with this row now. Minus 5 into minus 5 into 4, that's negative 20. 10 minus 1, 10 into minus 1, that's minus 10. Minus 5 into minus 5, that's 25. 10 into 3, that's 30. Minus 5 into 2, that's minus 10. 10 into 8, that's plus 80. And so 8 plus 3 is 11. Minus 10 minus 9, that's minus 19. That's going to be minus 20. Minus 30, that's 55. And that's going to be 70. And that is our matrix AC. Question 22. Solve the simultaneous equations, this and this, and show clear algebraic working. So we want to make y the subject and then insert this y here. So y is going to be 1 by 3 times 4 minus 2x. Now insert this value of y here. So 3x squared minus 10 by 3x plus 3 equals 2 into 1 by 3, 4 minus 2x. Okay, now multiply all the terms by 3 on both sides to cancel out the 1/3. We'll multiply both sides by 3. So get 9x squared minus 10x plus 9 equals 2 times 4 minus 2x, and that's 8 minus 4x. Okay, let's bring plus 8 to this side, that's minus 8, and plus minus 4x inside, that's plus 4x, and that becomes 0. So we get 9x squared minus 6x plus 1 equals 0. We have to show the quadratic formula here because the question says show clear algebraic working. X will be equal to minus b, so minus of minus 6, plus minus square root of b squared minus 4ac divided by 2a. Now you put that in the calculator, you get two values of x. One is 1 by 3 and the other is 1 by 3. And you insert this in the equation for y. Y was 1 by 3 into 4 minus 2 into 1 by 3. And this will come out to be 10 by 9. And that's our answer. Question 23 says the table shows information about the monthly wages of 100 employees at a company. The wage from 0 to 600, there's 7 employees, and 600 to 1200, that's 13, and the information are given. We have to calculate an estimate for the mean wage of the 100 employees. To find the mean wage, we have to find the midpoint for each of the class and multiply the midpoint by the frequency, and we have to add all of them. So that's going to be midpoint is 300 for this, 900 for this class, 1500 for this class, 2100 for this class, and 2700 for this class. How do you find the class midpoint? You find the average of the upper and the lower limits. So 600 plus 0 divided by 200, that's 300. And 1200 plus 600 divided by 2, that's going to be 900. And we did the same thing for all of them. All right. Now to find the mean wage, we have to multiply the frequency with the class midpoint for each of the rows and add all of them. So that's going to be 300 times 7, and divide all of this by the number of employees, so 100, and the mean is going to be 1710 pounds. Question B, the mean number of hours worked by the 100 employees last week was 33 hours, and the total number of hours worked by 91 of these employees last week was 2976 hours. Find the mean number of hours worked last week by the remaining 9 employees. So we have to find the mean of these 9 employees. So we have to find the sum of hours of these 9 employees and divide by 9 to get the mean, right? The mean number for all of the 100 employees was 33 hours. So the total hours worked by the number of employees equals 33. Okay, that's the mean. So total number of hours worked, that's 3300. So total number of hours worked by the 9 employees is going to be this 3300 minus the number of hours worked by the 91 employees. So 2976, and that is 324. Now, so mean hours is going to be the number of hours worked by the 9 employees, 324, divided by the number of employees, 9, and that's going to be 36 hours. Question 24 says the diagram shows the position of 2 boats A and B. We have a boat A here and a boat B here, and the position of a lighthouse L, that's a lighthouse, which are all in the same horizontal plane. So they're all in the same horizontal plane. The bearing of A from L is 50 degrees, so that's north, so that's going to be 50. That's 50 degrees. And the bearing of B from L is 125, so that's 125 degrees. The distance of A from L is 15 kilometers, and the distance of B from L is 22 kilometers. Calculate the bearing to the nearest degree of A from B. So if we draw an origin here, the bearing is going to be from the north up to A, so I have to find this angle. So that's going to be some 270 plus some angle. So to find the angle here, what we can do is we can draw a right angle triangle here and that's going to be 90 degrees. And if we can find this angle theta, the bearing is going to be 360 degrees minus theta. So to find, let's call this point M. And to find this angle theta, we need the lengths AM and BM. To find the length AM, we can find this entire length and subtract this much to find AM. And to get BM, we can add this length and this length together to get BM. Okay, so this length, to find this length, we have to find this angle, and this total angle is 180 minus 125, that's going to be 55 degrees. And so this length is going to be 55 sine 22. Sorry, so this length is going to be 22 sine 55, and this length is going to be 22 cos 55. The angle adjacent, the side adjacent to the angle is going to be cos, and the side opposite to the angle is going to be sine. Same goes over here, the angle is 50, so this is going to be 15 cos 50, and that's going to be 15 sine 50 degrees. So AM is going to be 22 sine 15 minus 15 sine 50, and BM is going to be 22 cos 55 plus 15 cos 50. So we have found BM and AM. The angle theta is going to be tan of theta. So tan theta is going to be opposite by adjacent. Opposite is AM, adjacent is BM, and so we get theta equals tan inverse AM by BM, and so theta comes out to be 16.35 degrees. So the bearing is going to be 360 minus theta, so 360 minus 16.35. So this is 343.64 degrees, and it asks you to give the bearing to the nearest degree. So that's going to be 344 degrees. Question 25 says the diagram shows a triangle OAB such that OA is A, so OA is A, and OB is 3B. M is the midpoint of OA, so OM is going to be half of A, and MA is going to be half of A because M is the midpoint. And N is the point on AB such that AN is 2, NB is 4 is 1. So that's 4 parts and that's 1 part. So AN is going to be 4/5 of AB, and NB is going to be 1/5 of AB. All right. Now you're asked to express MB in terms of A and B. So to find MB. So MB is MO plus OB. We can go from M to O and then O to B. So MO plus OB. MO is minus half A because we're going in the opposite direction, and plus 3B. And that's our answer, minus half A plus 3B. Question B, express ON in terms of A and B. You have to find ON. So we can go from O to A and then from A to N. That's going to be ON. And we already know, we don't know AN yet, so we have to find AB first. Okay, so let's write it down. So ON is going to be OA plus AN, and OA is A plus AN is 4/5 of AB. We have to find AB first. AB can be written as AO plus OB. AO is minus A and OB is 3B. So that's going to be A plus 4/5 of minus A plus 3B. So that comes out to be A by 5 plus 12 by 5B. That's our answer. A by 5, or 1 by 5A plus 12 by 5B. Given that X is the point such that OXN and MXB are straight lines, find a simplified expression for AX. We need to find the expression for AX. So AX can be found from A to O and then from O to X, but we don't know X. So first we'll find out X. Okay, so let's think of a triangle. We can consider this OMX triangle. In triangle OMX, you can see OM plus MX is going to be OX. We already know OM, but we don't know MX. But we do know MB, so we can write MX is some multiple, let's say P times MB. We have already found MB in part A, and OX is unknown, but we know ON. So OX can be written as some multiple Q of ON. OM is half A plus MB was minus half A plus 3B, and Q times ON was found to be 1 by 5A plus 12 by 5B. All right, now I'll separate A's and B's. So if I factor out A, that's going to be half plus half minus B by 2A. And if I separate b, that's going to be 3b. That's equal to a into q by 5 plus b into 12q by 5. Now we're going to compare the coefficients of a and b. Comparing the coefficients of a, we get half minus b by 2 equals q by 5. That's going to be 5 minus 5b equals 2q. So we get 2, 5b plus 2q equals 5. That's our first equation. And comparing the coefficients of b, we would get 3b is equal to 12q by 5. So that's going to be 15b minus 12q equals 0. That's our second equation. And solving these two equations give you p equals 2 by 3 and q equals 5 by 6. Okay, so we have found our p and q, and ox is q times on. So ox is q times on. Therefore, ax, that's what the question asks. Ax is going to be ao plus ox. That's minus a plus q. That's 5 by 6 times on was 1 by 5, a plus 12 by 5b. And that simplifies to minus a plus 1 by 6a plus 2b. Alright, so we get negative 5 by 6a plus 2b. That's our ax. Question 26 is an inequality question. Solve the inequality of this. So that's going to be 3x. I'll bring a negative 2x over to this side. We get plus 2x is less than 15. Minus 5 goes to the side. Gets positive. Get 5x is less than 20. So x is less than 4. X is less than 4. Question B. Solve the inequality x into x minus 1 more than 6. So that's a quadratic inequality. So x squared x minus 6 is more than 0. Now, this if x squared minus x minus 6 were equal to 0, then we'll get two solutions for this, 3 and minus 2. Okay, now this quadratic equation will be a smiley face because the coefficient of x squared is positive. So we can, if we sketch a graph for this, it's going to be something like this, where it cuts here at negative 2 and here at 3. And we need this to be positive. So this curve needs to be positive, and it's positive in this region and in this region. Okay, so to get this region, we have to go to the right of 3. So x must be more than 3, or to the left of minus 2. So x is less than minus 2. And that is our answer. Therefore, x should be less than minus 2, or x is more than 3. Now, part C says, hence find the range of values of x for which both this and this are true. Okay, so for the first one, we have found x is less than 4. So this was x is less than 4, and this one was x is less than minus 2, and x is more than 3. Now to do this, I will draw a number line to make things simpler. So that's 0, say that's 4. So the first inequality is true if x is less than 4. And the second inequality is true for, let's say that's minus 2, and that's 3. So for this. Okay, so we'll take the common parts only. So the common regions are this and this part. Okay, so the range of values of x would be x is less than minus 2, or x is more than 3 but less than 4. That's our answer. And that was the end of paper 1.